Let's give a warm welcome to Mr. Parth Thakkar. Mr. Parth Thakkar, Director, Paul Frost Aircon, is MSc in Building Services Engineering with Sustainable Energy from Brunel University, London. He is BE Mechanical, Mumbai University, and 7 years of working experience in the field of cold chain equipment manufacturing. He is constantly working on innovation in the field of refrigeration. Mr. Parth is presently involved in Make in India shift happening in refrigeration equipment manufacturing sector in India. Today, Mr. Park will be sharing his insights on IoT in refrigeration and its advantages.
We've had a good panel discussion and we've got to understand lot many things in a very short span of time about what is happening in terms of digitization and in terms of energy efficiency and kind of the latest stuff happening in the field with whatever we've heard since the big, start of today's event. Coming to the backbone or coming to what actually can enable all of this to happen. And speaking of the technology or the optimization that I was actually talking about, that's what my presentation is all going to be showing. It's basically an overview on all of these topics. And if any questions, you all can just interrupt me in between and ask whatever you would want to. Basically, introduction to IoT in refrigeration can be as simple as knowing the fact that you are going to be able to see each and everything happening inside of the refrigeration system and the refrigeration equipment. What sub equipment or what sub assembly is performing at what level? What is the system saying to you? What does it want to communicate to you? What attention is being demanded in what part of the system where? So the outline is going to be like, we're going to know the basics of IoT. What are the tools for understanding the IoT infrastructure and the domain of improvement that we have been talking about, or the optimization that we've been talking about, and integrating the components and reaping the benefits from there on. So basics, yeah, we've been hearing so many things since morning, since today's start of today's event. And I think a lot of basics are clear. Apart from that, when we speak of the types of IoT infrastructure that can be available, there can be cloud-based servers, there can be local servers, there can be static IP-based networks which are remotely accessible for companies who can't share data out of their devices. GPS and GPRS or 3G based logistics monitoring, what Jet previously talked about and also what Vishnu previously talked about. So what we need is, we need to know the basics. We need to know the types of the systems, and we need to have a basic interest on actually implementing these things. What can we basically monitor? We can have real-time monitoring of uh, any equipment in the cold chain that you would want to monitor, be it a VC cooler, be it a deep freezer, be it a cold chain warehouse, be it a truck. You can today monitor everything real time. And be it any type of compressor, which I have shown here in this image, trust me, you can monitor the performance of each and every type of system which is available in the market. It is something that has become so easy and so intrinsic to the system that it's a cakewalk, I would say, but only to the people who are really interested, who are really going to the basics, who are wanting to implement everything to the T. It's actually a cakewalk for someone with that kind of an interest in the real implementation. What it can also give you is increased efficiency when you know what your system is performing like, when you know what it wants to speak with you, when you know its pain points. You can actually work towards optimizing the data and the performance day in, day out. You can look at what's going wrong. You can look at what's working perfectly. You can diagnose the system like how a doctor would diagnose a patient. So, when he checks your blood pressure, when he checks your heart rate, that's the kind of diagnosis or monitoring that you can do with your system if you have IoT installed in place. Service monitoring and service integration with IoT is another added benefit, because when you know what's going wrong, you don't have to go to the field check what's going wrong, and then come back for the service. You already know what's going wrong in the system. You already know the pain point. And when the service person goes to the field, he goes prepared with what's to be rectified. So it's basically a reduction in the service cost for the service provider or for the OEM, which can ultimately provide a relief in the operating costs going forward into the life of the equipment. Not only that, but it also helps you do a lot of preventive maintenance, because preventive maintenance is the key to not having breakdowns in the equipment. And a cold chain equipment failing is kind of a nightmare. Ask any cold chain equipment operator, and he will tell you it's the worst nightmare that he will ever go through. So not having breakdowns because of having a strong predictive maintenance would be one of the key advantages of implementing the IoT inside of our refrigeration equipment. Enhanced control. You can also have a communication with your system, with your equipment at any point of time. Any kind of alerts coming to you from the system via the phone app or via the website will always have a very seamless input taking capability from you at the user end. As you can change the parameters, you can hit defrost at any time, you can switch on and switch off the equipment as per whatever automation you would want to set it. And that's the level of enhanced control that we are talking of. When we speak of last mile logistics and when we speak of ultimate flexibility, that's the kind of control that we are looking at. Then we have asset controls and monitors, like we are talking about 3,000 cold storages being used by the Celsius team. That's something that is a humongous task to do. And like Rajat said, it's impossible to go into every cold storage every morning and check what's going wrong. The asset controls and the asset monitoring facilities that IoT can provide you with can actually bring in benefits of scale and help you realize the benefits of scale in cold chain. Stock management, we have already spoken about WMS, and consumer engagement is also something that is a very good tool because of having app on your mobile phone, which makes it easy to operate. You can also push data into that app and keep making the customer aware about timely maintenance and stuff like that. Sales, yeah, that's something we are all interested in, and you can also keep pushing sales data into the app. But okay, that's the business side of it. Power consumption nature of the condenser, ambient temperature, door openings, defrost cycles, humidity levels, the room temperature, compressor on-off cycles, any leakage in the coil, the size of the frost getting built up, the location of the equipment, everything can be monitored seamlessly. And that's the kind of advantage that we are speaking of when we speak of IoT. Now, what are the types of IoT systems? The types of IoT systems are based on architecture of the system that you want to implement. Like we spoke previously, is it a static system that you want to deploy? Is it a dynamic system on field that you want to monitor? Is it something that is inside of a vehicle that you are? So that's the type of architecture and the type of application that we are talking of. The complexity of analytics also define the type of IoT system that you can implement. If you don't really want a lot of analytics and a lot of preventive maintenance guidelines coming in from your system architecture, you really don't need a very complex IoT system. You can make do with something quite basic as well. Components that are used in an IoT environment, this is something that makes up the infrastructure. Rajat happened to show a detailed piece by piece photo data of all these things. There are sensors, there are controllers, there are gateways, there is a cloud, and then there is the feedback mechanism and the analytics that we are talking of. Sensors being primary X-ray into a system. So whenever you have a sensor that can give you data on the temperature, on the door openings, on the pressures of the system, you have got inside of the heart of the system and you are monitoring everything inside out. The higher the number of data points, the higher will be the ability of an IoT environment to perform at peak performance levels and give you the maximum control over your equipment and for you to reap the benefits out. Sensors today are also available in wireless modes, which makes it very flexible for anyone to implement an IoT infrastructure and start monitoring what is important to them. The second most valuable thing that I would say inside of an IoT architecture or an IoT environment is the analytics. If you are not building analytics out of the data that you're getting, again, makes no point for you to implement it because you're simply not using the data to its peak. While that cannot take much away from you from an IoT system, the main point being the visibility of data and the visibility of performance. Analytics is something that is definitely going to be the future. It's definitely something that will help you reduce a dependency on manpower. It is definitely something that's going to help you reduce dependence on the intelligence of your team. It's going to do wonders for us in the future as far as system performance goes and as far as predictive maintenance. So it's also going to be of prime importance when we talk of temperature integrity and the visibility throughout the cold chain. So that is something that the analytics is going to build for us. Now, when we talk of integration and when we talk of having final end result of achieving all what we talked about, it is how you are integrating the bits and pieces of the IoT infrastructure into the system that you are building. And that starts right from the equipment selection during your refrigeration equipment design. And every bit of the data that you use to build the refrigeration system will need you to think of IoT. How can it be integrated into the system, whether it is an entire warehouse, whether it is a processing plant, or whether it is a truck. You will need to know the operating points of the system. You will need to know the usage patterns, and you will need to know everything that can integrate or which can fail an IoT component coming inside of it. So that's how critical the integration of IoT equipment is during the system selection stage, because it can start giving you data from day one, or it cannot give you constructive data at all, depending on what you are deploying there. So that's these 7-8 points that I'm speaking of here: the equipment being designed, the operating mechanism that is being used, the delta T of the equipment, because these things really define the type of sensors that you can use, the mode of data collection, then the size of the evaporator, and what type of defrosting you are going to use, size of the equipment, primarily defining what kind of walls are going inside the system, whether the walls can communicate with the sensors or whether the walls can directly give you data into your cloud. Is your system having that kind of a capability, or is there scope of such an implementation at all? What is the condenser side of the system? How is that going to be designed? And finally, designing for the environment, whether you want energy optimization, whether you want energy efficiency to kick in after the few months or the first few initial months of performance of the system, or are you just looking at basic data? All of these things define what kind of IoT architecture and what kind of system integration can be done in terms of IoT inside of the refrigeration. When we come to function of each of the equipment, the sensors basically do the sensing part. They sense what temperature is being achieved, what was the set point, how close are we to achieving the set point, and stuff like that. And second function of the sensors is to give you the feedback into the loop. When we have a cutoff point and when we have a kick-in point for the compressors to start and stop, that's basically one kind of a feedback that we are always having into the loop of the system. Now, sensors coming in with their feedback mechanism can bring in a lot of inputs, and we can bring in a lot of improvements into the system going forward. So they can tell you whether one parameter working right should shut off the entire system. Sorry, working wrong should shut off the entire system, or should it just shut off one part of the system and keep the rest of the equipment going? So that's the kind of capability that the sensors can come in with. Then we have the controllers providing the input outputs and providing the controlling part. The controllers these days also have come up with a lot of variety. In all the OEMs have come up with different types of controllers, some providing capabilities, some providing you direct cloud capabilities, and a lot of improvements coming out in the market these days. The gateway is one of the most important equipments inside of an IoT infrastructure. It is the heart of the system as far as the communication to the cloud and vice versa is concerned. It is something that is like the control room of the equipment. The cloud, obviously, being the last and the most critical piece of the architecture, finally relaying the data to the operator and from the equipment. So that's the capability each of the equipment or each of the sub assemblies comes with inside of the IoT architecture. And all of the above only and only lead to higher visibility on system performance. You don't have one of these, and there's no point thinking of IoT. Like if you don't have the gateway that can be powered by 4G or 3G SIM card or via Ethernet instead of a setup, and there's no point going to be implementing an IoT that works on the cloud. You might as well implement an IoT system that works on a local, what do you say, local server, and that server can then be accessed whenever you are inside the setup, because you're simply not going to be able to use the gateway relaying data to the cloud, and you're not going to be able to access it remotely. So that's how critical each component is. And there is always scope for energy efficiency. To put it out there in simple words, we as refrigeration engineers of tomorrow need to engineer for OpEx and not for CapEx. That is the only thing that I've been saying since the beginning of this seminar today, that operating costs are something that we need to always keep optimizing on and not the capital expenditures, because in the long run of things, what we have always observed is the operating cost is always the majority cost or in the larger scheme of things. When you have operated an equipment for its life cycle of maybe 10 years, 8 years, your capex is something that barely goes beyond 33-35%, and the majority of the cost being the operating expenditure. So my only request would be to not use the energy at all, like Rajat and Vishnu are today wanting to drive away refrigerants altogether if they can, and to drive away dependency on fossil fuels. That is what would be the goal, that you don't use energy, and that would be the greenest that we are waiting for. And as sustainable and as net zero as we may want to think of, refrigeration today stands far from being net zero, because it is a very highly energy intensive field, and we can only optimize and optimize it up. So that's about it from my end. Thank you, TCB team, for giving us the opportunity. Thanks a lot.
Thank you, Mr. Parth, for highlighting your views on IoT in refrigeration and its advantages. We request our delegates and viewers to stay connected with us on our social media handle. Thermal Control Magazine is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. With this, we want to announce the closing of today's session. Request you to stay tuned for more such sessions. Thank you and goodbye.